No, I'm starting now. LeetCode. Gracias. Hello everyone, it's September 15th. Alright, well, we have maximum score from performing multiplication operations. Alright. You're given two integer arrays, nums and multipliers of size n and m. N is larger or equal to m. The arrays are one indexed. What? Why? You begin with a score of 0. You want to perform exactly m operations. M operations. So, number of this. On the ith operation, one index, you will choose one integer x from either the start or end of nums. Add multipliers. Oh, wait, hold on. So first, second, but it's one index. Okay, I see why they want a one index. So we'll do multipliers I, okay, times x to your score. Remove x from the array. Return the maximum score after performing m operations. So we are performing them one by one, right? Because we have the first operation, the second operation. So first operation, second operation. So basically we see 3. Do I multiply it by 3 or multiply by 1? And once that's done, 2, do I multiply by what? And then 1 multiply by what? So the optimal will be 3 multiplied by 3, 2 multiplied by 2, and then, of course. Oh, this is interesting. Now we have a positive and negative. Wow. Okay. So, at each stop, we have two options, right? I mean, ideally, you should just pick the larger one among the two. If I have a choice, if you think about, but the multipliers are not sorted, right? So I can think of a situation where, like, if we swap 2 and 3, that's actually a good test case. Let's see. If we swap 2 and 3, we actually leave this, but we swap 2 and 3. So I would say 2 times 1, 3 times 3, that's, we can see, that's 9, 9 plus 2 is 11, 11 plus 2 is 13. I say it's 13. Let's see if it's 13. Yes, it's 13. So you can't just go with the largest value, right? So if you can't, I mean, we can do, what do we do? I can say, so either choose this or choose this. If I choose this, then the remaining with this. If I choose this, then the remaining with this, right? Maybe, I don't know, maybe we can DP it. I mean, I just need a start and end, right? Just start and end and the current index on the multipliers. And we want to find the maximum. So like, I want to find a maximum. Let's try. So basically we have 3. That's 3. It's not 2. It's 3 values. It's 3 values. Oh. N is 10 to the 5th. Nah, I don't think that's the way to go though, man. Huh. Okay, hold on. This is actually not a good test case because 2 times 3 is 6. Alright, let's make this one bigger. How do I make it 4? So, for 2, 12 plus 2 is 14. 16. If it's 8, 6, 14. 50. 50. Oh. It should be 16, right? Yeah, it's 16. Yeah, you should do 2 times 2 and 3 times 4. Interesting. I mean, the multipliers, we can sort them. But it's possible we sort them. Let's say from large to small, we can sort them. It's the purpose of sorting them, right? I mean, negative value, that's like, this one's obvious. Minus 10 needs to be picked minus 5. Minus 5 needs to pick minus 3. 3, oh, I can pick 1. Or I can pick minus 3. And because they're all larger, so 3 needs to pick. So we have to pick the minus. Yeah, 3 needs to pick up the minus 3. Because if 3 doesn't pick up minus 3, let's say 3 pick up 1, and then 4 has to. If 4 can hit 7, 4 so 4 hits 7, then we have the minus 12. They take this. Let's take this. And this take this, okay, and the result is the same. Maybe it is DP, but we have 3 values. We have 3 values for DP. Damn. Let me think again. So if we have a low and a high on nums, right? And basically we just want to find all the low-high combination. All the low-high combination. That's a lot of low-high combinations, man. All the low-high combinations for. We can try to see if it's too slow, then we fix something else. Because at the moment I don't have another idea. Huh? Should be 16. Ah, shoot. Man, there's a lot of things wrong. Hold on. I'm gonna reset this and then get amend. Oh, hold on. Probably spelled wrong. Should be 14. Right? Okay, then we're gonna copy 16. There we go. Yeah, I'm not 100% sure on this one. I mean, it does look like DP to me, but I don't know. So DP from from functools port. Okay, DFS. We have 3. We have low, high. Right, low, high, and index. So this is gonna return int. So we have a low and high. So this is the current low and high, and I have the index. Now we decide which one to take. So we say we either take this or we take this, right? So we take this. So we say, what do we say? We say we take low, right? And eventually, if low and high is equal, that still go, right? But if low and high will always, so if it equals low will plus 1, or high minus 1, then that shall return 0, right? So we say if low is larger than high, this one will return 0. It doesn't matter where index is. But actually, index will get out first. So we say m equals, m is len multipliers, n is len nums, okay? And we say if index is equal to m, right, and then return 0. Otherwise, we're gonna say if index is take low or we take high, right? And then we say if low and is equal to high, right? Then we return multipliers index multiplied by nums low. Otherwise, then we can take low, so multiplier, so we're gonna return the maximum of what? Of, no, I will take multipliers index times nums low, I take this, and plus the remaining DFS, low plus 1, high, right? The index plus 1. And in this case, I don't really need this one, right? And index will take high, then low doesn't change. But high minus 1 at index. Then we just do this. And then we are going to area cache max size equals none. Then we're gonna do DFS. Low is 0, high is m minus 1, index is 0. Alright, so we just return this. I don't know. Give this a shot. 14. Actually, we can do the same thing. Just change 2, 3. 2 and 3. I believe this one is, I just forgot. This one is 16, okay? This one is 16, so we'll go 4. This one is 16, okay? And this is a 102. I think this one will work, but it's not going to be fast. Most likely it's not going to be fast, so I am worried that this one will time out. If it times out, let's run it. Yeah, I know it passes, but it could time out. Let's see if it times out. And most likely it is. That doesn't matter. I'm gonna have to try it first. Yeah, times out. Okay, it's fine. So we know it times out. Alright, so I have to be smarter than this. How? Like, how? So multipliers, it is sorted? I never say it's sorted. So if it's, let's say it's from small to large, it's sorted, right? So every one needs to be multiplied by hmm. Hmm. Yeah, I have no idea. How do you approach this? Yeah, the thing is you never know. Or you can, I don't know, right? Look for the best opportunity for every single one. Like let's say minus 10. I need a large and minus value. So we say, okay, then we pick minus 5. But why? Yeah, it could be something bigger. Let's say this one's a minus 100, right? But the thing, if this one is minus 100, you should definitely take 1 and let minus 100 to take minus 5. That's exactly the thing. That it's just not, we're not sure. Hmm. Hmm. But I just realized we don't need low and high. I just need a low, because I can deduce where the high is, right? So, for instance, I know the index, which is the number of things here that's left, right? So if index is 0, that means we have gone through 0. If index is 1, that means we have gone through 1. So if index is 1 and I have a low is this, that means the high must be minus. So we can do, let's don't do high. Let's just go low and index, right? This is still valid. We just need to compute what high is. Now what is high? So high shall equal to, so index, we can do m minus index. That's number of things we have gone through, right? Number of things that we have gone through. Right. So, and now I have the low. So low is the number of this on the left side has gone through, right? So the number of, so we do this minus low is the number of elements has gone through on this side, right? So then we just say n minus this thing. If we do n minus this thing is a number on this side, right? If I've gone through 1, we've gone through 2, we're going through 1, then it should be this minus, so maybe my minus 1 again. It will be like this. So I don't have to pass this, don't have to pass this, but I have high, I compute high. Let's see. Oopsie doozy, not 100% correct. Okay, that's fine. That is fine. We need to compute a high better. Okay, so again, index is 0, right? If it's 0 to start, low is 0. So high, yeah, that's not right. That's not right. Come on. N minus is the number that has gone through. M minus index. No, index is the number that has gone through. Right? That's the number. Alright. Let's try this. Let's try this. Don't put it here. So now I have 2, so it should be OMN. I should have tried it first. Alright, still not gonna work. So it's fine. That is fine. Memory limit. Huh. Wait, hold on.
There's some broccoli here.
Yeah, I haven't taken it yet. Oh, this is evil.
Okay.
Yeah, it's good. Only 34. Oh, this would take 44. So this is actually worse. Oh no, of course, this is a low-high index, that's worse. So, yeah, that's 3, right? You cache in 3. This one you're caching like 2, but to get a memory limit. Alright. Memory limit. What else can you do? I don't know. What else can I do? This is actually not TLE. This is a memory limit. So it's MLE, memory limit, exceed. Ooh. It seems to be greedy, right? I feel like a problem like this is like greedy, but how do we do greedy? How do we do greedy? I mean, you can't. You can't say at every step you pick the largest. That ain't gonna work. Then you have to pick both. Alright, I actually have no idea. Let's see, read the topic. It is DP. So we just need to find a better way to do DP. Okay. A better way to do DP. How? What else way we can think of doing DP on this thing? Like, what other than this? Is there another way? Lord. Man, this is evil. Dude, this is evil, man. It's not a speed problem, it's the memory problem. Don't use area cache. If we use, I don't know, is this going to be faster? Huh. Are you telling me that it will be better to use to hand roll So we're gonna do, this is damn, how many columns? Low is n, become n rows and m columns, and we can swap them, it's fine, right? So become m, right, multipliers on the columns. No, hold on, m on the rows, and this for this in range n, right? So m columns and n. Well, hold on. Oh yeah. Well, we have to. We can reduce to m and by m. It could be m by m. Because low either +1 and AS +1, so at most is m. So he's saying we can do it this way, m by m, right? Now we don't cache it. We just say if yeah, this is always this. And if dp low n index is larger than minus master infinite, that means we have populated already, right? Then we return, oh actually we say if it's equal to, alright, then we do this, and then we say choice C1 equal to this, C2 equal to this. Wait, hold on, this is C2. Okay, so choice 1, choice 2. So I have two choices. And in fact, I can just put this one in it. Alright, so I have choice 1 and choice 2. Then we say dp low index equals maximum C1, C2. And once we're done, we return dp C1. No. Low index. And I will do this. I don't know. Okay. I'm basically rolling my own. I'll be very surprised if this one is faster or doesn't use as much memory. Let's see. Nope. Lord. Oh, Lord. That was huge. I think the previous one we got a 44. Do we get here? Only 35. No, it's slow. It's slow. This is a time issue. Okay. So that's not working. It's actually worse. Yeah, it's actually worse. Probably can't even pass this one. Try it. Yeah, it's worse. This is worse. Oh, by itself is not that bad. But the next thing you would think is, let's not do it this way. Let's do it bottom up. You know, maybe bottom up will be faster. How do you do bottom up? Yeah, that's my last trick. If bottom up still doesn't work, we'll check the solution. Check the hints. Okay, bottom up. So it's always, it's basically a m by m matrix, right? And then we start from 0, 0. To know 0, 0, I need to know this, plus 1, and a low, or there's low in a row, right? So low and the index plus 1, so column plus 1. So I need to know these two. So to know this, I need to do this comes in here, this comes in here. Okay. And to know this, so to know this, I need to know it's always index plus 1. So I need to know this and this to know this, this and this to know this, this and this to know this. So this will be the first one that does not require anything. So the rightmost column. So what is the rightmost column? Yeah, we can go rightmost column. Rightmost column, which is index is equal to m minus 1, and low is 0, 1, 2, 3. So index, so that's the last one, okay? And index is 0, 1, 2, 3. It means it's the last one, and you are either this, this, this. Then you just multiply them, right? There's nothing that you can do, right? So if we go on a slightly different, let's say bottom up, right? This is the same. And then, well, what the reason is, when index is n minus 1, all right, so this is m minus 1. So index is m minus 1 minus low minus 1 and minus this. So we need to know where do we get it. Oh, the high will be, oof. Oh, but it doesn't matter. We'll just compute. Yeah, because that's the last one. That's the last one. So we just go through the whole thing. Yeah. So that's the high. Right. So what do we do? What do we do? What do we do here? Well, we can populate this row first and then do it, but it will be either plus 1. So this equal to this the maximum of the maximum of this plus this, which is because this will be 0, because on the right side will be 0, this will be 0, right? This will be 0. So what we can do is we get one more column. So we get one more column. Let's say we do m plus 1. Okay, we get one more column. And then we say for j in range, right, m minus 1 to 0, for I in range we need these two, and we have done. We need these two. And this we need these two. Wait, hold on. Low plus 1 and index plus 1. Index is column. That's why I say if index plus 1, that's going to come out. But low plus 1, I can allow low plus 1, right? But no, low cannot be more than m, which is you just keep taking the left, and most m. So if low plus 1, yeah, that will be also 0. So for this, will be 0. So maybe we can also do one more on this. I'm not sure if it's wise to do this. Actually, I don't like it. I don't like it. We just go this way. Okay? Just m. And then we use an if. Memory wise. Right? So this one also, that's going to be to m. Okay? So everybody is going to say, so C1 is going to be equal to, so we'll do exactly like this. Actually, instead of j, this is index. This is low, right? So we can do this. This and that plus 0 if, say, low plus 1 is equal to m, or index plus 1 is equal to m. Else, dp, low plus 1, index plus 1. And here is the same thing. So we just copy this. I'm pretty sure low is not going to be, so we don't have to do low. We just do index plus 1. So this is going to be index plus 1, low and index plus 1. All right. and we say dp low and index equals maximum c1 and c2. And at the end, we return dp00. Okay, number 3. Out of range. Where? Which index out of range? Huh. I don't understand. So low and index. Low is 2. Index is 1. Low is 2. I can do dp2. Zero, 1, 2. 0, 1, 2. Yeah, I can do that. Where? Is this one? N minus... No, what? I'll do high. Low, high index. How about this? High. High is too much. How is that possible? Say low is 2. Oh, low cannot be larger than... low cannot be larger than index. It makes sense, right? So this should be range to index. Right? It should be index. Because low cannot go larger than index. Okay, let's try attempt number 3. Try this and then try the, yeah, try this. Try both. Damn. It's a memory thing. I don't know. I'll try it first. Oh, this might be memory limit, but if it's memory limit, I have a solution. We don't need all of this. Time limit. It's time limit. We don't need to set up the whole thing. We only need 2 columns. That's all we need. 2 columns. Actually, I'll try to make that into rows. So I'm going to swap them and make them into rows. So actually I'm going to make rows. So this one will equal to this and this, right? Yeah, rows will be easier to deal with. I just need to figure out how to swap them. So dp is going to be a single thing. And I didn't even need to be. The dp is just going to be this. That's it. That's the dp. And for index, yeah, it's fine. Index is going to be this. For low is going to be this. High is going to be this, which is fine. And this is going to be, these are fine. This is also fine. It's just here, right? 0 is either 0 or, so this is a plus 1 plus 1. So that should be dp something. Now I believe this shall be dp so low plus 1, index plus 1. So it's dp, what's that? That's low, right? That's low. So index is column, low. So low plus 1. And this is just going to be dp low. All right? And for each one, there's going to be like, if we do from this, so this equals this and this, updated. This equals, oh, we'll update. Probably shouldn't do that. Yeah, I don't think we should update. Because this depends on this and this. This depends on this and this. Right? So if we update, there's a new value. Oh, we can just do 1, right? So this, so if I have this one, right? The next value equals the maximum between these two. Then we get a maximum, update this, go to the next one. This one doesn't use anymore. So I can do on the same thing. All right, so we do this, and then we say dp low equal to this. That's it. dp low equal to this. Because I did low on this, and then we update this, and next one, low goes a little bit higher. And in this case, I don't even need index plus 1. And then we're going to return dp0. All right, so this bottom up, what's it called? 1D, bottom 1D dp. Like seriously, if this one still is not right, then I have no clue. I have literally no clue. Again, try this. Ooh, looks faster, huh? Come on. Show me. Show me. Give me some. Give me some. Alright, it's a different problem. This is a different problem. We got a wrong answer. Okay, okie dokie. How is this wrong? Man, you're killing me here. Oh, it's an early one. Output. Expected. Damn. 32. Early in the... Okay. Yep, that's not right. How? Something we did wrong? Oh, I should have gotten this one out. It's actually quite important because the rewrite has to happen from this one. Man. This is 3. 2D DP, right? Yeah, let's just see if this one's right. Okay, it passes. So this one passes, but this one fails. Which means the problem is how we rewrite it, right? That's how we rewrite it. That's cool. That's cool with me. We just need to figure out what went wrong during the rewrite process. That's okay. All right, let's see. Actually, I don't know. Okay. So this will equal to this and this, right? This and this, and I update it here. And that's the last one. And the next one, so low will go a little bit smaller is equal to this and this. Yeah, it looks cool. It looks good to me. Maybe I need this one. Yep, that's it. Why do I remove it? Right? Why do I remove it? Okay, this. All right, let's try this one. Again, I'll try this, run through this. Everything looks good. Remove this, go again. All right, try it. Judging. Man. Oh, that's still not good. All right, now I'm out of options. Literally out of options. Yeah, we'll go back to 44. We go back to 44 out of 50. What is the trick, man? Let's see. Maybe we can reduce the if and else. Yep, we can reduce if and else because the last one will not change. Okay, the last one will change, but with But honestly, I don't think that's it may be. It's a lot of if and else. So if we can reduce the amount of if and else, let's try. I just don't want to give up. I seriously think like how unless there are better setup, right? Without if else. Unless there's a better setup. I don't buy it. Alright? So the first column, the first one, is all 0. So it's just a maximum of these two, which means for this, I shall say, I don't know, for low in range, M, right? everything shall be the maximum of something and something. So what is the something? The first something is this. Okay, that's the first something. And index is n minus 1. And the second something is this thing, because everybody else is 0. And this is n minus 1. And high, I just have to do it this way. Okay, high is this. And index is n minus 1. Okay, index is n minus 1. So m minus 1. So we can do minus m plus 1 plus low and minus 1. So minus 1 and then plus 1 canceled out. So that is our first DP, the first column. And then I can say from n minus 2, right? And for low in range to index. So we don't do the last index. Okay? We don't do the last, because the last index I'm going to do by myself, because it's only going to be one possibility. So we can get high, and we don't need all this. This is just going to be, because it's not going to be index plus 1 is not going to be m. So it's going to be plus. All right, this is going to be plus. That's going to be maximum of these two. All right, once we're done, we need to do dp index. Right, dp index, because this one I don't do index. Now we do dp index shall equal to, there's only one option, right? There's only one option. It is dp index, the previous dp index, plus something. Plus what? Plus, so what we have is, yeah, which situation do we have? Plus 1, plus 1? No, we're gonna take, wait, hold on. If we take low, right, if we take low, that's gonna be plus 1, plus 1. If we take high, so we have to take high, right? We have to take high. So it doesn't change, the low doesn't change, because that's what we want. So I have to take high, so I have to take this high, okay? So we take high plus this index. But what is high? Well, high is equal to n minus index minus low. Well, index, not low, is index, so that's 0. So n minus 1 in this situation. So yeah, like this, we don't have any if and else. Solution 5. Let's see. Oh, that ain't right. That ain't right, man. Oh, the first one passed. The second one failed. How? Oh, I still need this, right? I still need this. It's just going to be, there's just no additional. This additional will be 0. Screw you. Oh, that's not low, that's index. Oh, why? Huh. hold on. Let's see if this one is correct. Okay, this one's correct, which means it's correct. I just need to it's correct. That's not how I imagined it to be. Really? It's correct? Oh yeah. All you worry about is +1. I don't worry about... that's correct. Alright, so this is no if and else. Honestly, I don't think it's gonna make a difference, but we try it. No if and else. And we passed. My God. God. Alright, that's quite a journey, right? That's quite a journey. So, so the trick is to avoid if and else. Can you even believe that? Can you even believe that? Either that, or we just... Yeah, either that, or... I mean, I don't know. I cannot believe it. I seriously cannot believe it. Like, just because of the if and else? I mean, how much time does it take to do if and else in Python? It's so slow. It's exactly the same thing, right? We just do some if and else, and it cost us to go from TLE to 99%. Just see what happened there. If and else to 99%. This is incredible. This is... Well, what a journey. No, that's TLE. This is still TLE. I think they are all TLE. Yeah, all TLE. TLE, TLE. Alright, so this is the one. I don't know what to say. See how people don't like this problem. Yeah, it's tricky. So runtime is OM squared. Alright, this one is OM squared. And with this. What a journey, right? What a journey. Cache, LRU cache times out. So I switched to 2D DP. 2D DP memory exceeds. So I switched to 1D DP. Then what happened? 2D DP. No, this is 2D DP. This is also 2D. So first is 2D DP with recursion, right? So times that, so I switch 2D DP using switch to 2D DP top down. Switch to 2D DP bottom up. And 2D DP bottom up TLE MLE memory limit exceeds time limit exceed exceeded, right? I think it says exceeded. Yeah. TLE exceeded. To the DP top down, memory limit exceeded, so I switched to the bottom up. TLE, so I switched to 1D DP bottom up, right? So I switched to, that's bottom up 2D, so I switched to 1D DP bottom up. And then 1D DP bottom up TLE. So I removed all the if-else statement. And 1D DP bottom up without if-else passed with 99% with very good time. Can you believe it? How slow is Python's if and else? Apparently it's very slow. Yeah, the problem itself is not that difficult if you like kind of understand it. Yeah, the problem itself is pretty standard DP, but to go from the easiest, but there are to go from a 3-level, right? 3-level, low, high, and index to just 2-level, low, high, requires some ingenuity. Then to go from 2D to 1D DP requires a bit more ingenuity. Not ingenuity, but more patience. Yeah, that's all I have to say. All right, let's see. Yeah, it doesn't work. Greedy doesn't work. Greedy, short-sighted. That's true. Brute force is M. Why would you do string slicing, right? Because of DP. Yeah. So you only need 2. Yep. So you have to be smarter. M squared, exactly. You have to do iterative. So Oh, you use n+1. I was so afraid. When I do n+1, I was so afraid that it's going to time out as well. But it seems like you can do +1. It's okay. I mean, So it's okay, right? We went directly for space optimized. That's what we did. Directly for space optimized. Oh, really? I use Python. (2025) August 25th, 26th. Yep, it's very tight for Python. Very, very tight, I think. Yeah. All right, that's it. Wow, what a journey. What a journey. Clear the cache. How'd you clear the cache? Oh, clear the cache. My man clears the cache. Wow, I never write like solution 6. Wait, so I have to record the values first. Yeah. As I have to record, so result equal record the value first. How do I clear the cache? Oh wow, I did not know that. DFS dot clear, cache clear, and then return res. Okay, I'll try this. Really? Really? Let's see. I'm curious. See if it works. Nope. Still doesn't work. Still doesn't work. Oh man. Nope. Still TLE. Has to be bottom up. I mean, maybe bottom up on 2D. I think it might work. Let's do this. Bottom up 2D, but we make it so, yeah. Wow, solution 7. So bottom up 2D without if else, but with additional, right? With additional column. So we're gonna do n+1. Actually, it doesn't matter. This we can just do 0. Maybe it'll make it even faster if I just do 0. Rows doesn't matter. It's the column. And we'll just add it. We'll just add it. Index out of range. How? How is the index out of range? Oh, I guess we have to go +1 as well. There we go. Okay, solution number 7. Try it. That's ridiculous. This also doesn't pass. I think this is exactly the same. Like, what's the difference between this and, let's say, recursive doesn't pass anymore. Iterative. n+1, n+1. This is exactly the same. Yeah? So this one still doesn't pass. Oh, wow. How tight is it? This is a little bit ridiculous. I think I'm gonna write something. And I'm gonna rearrange them. I'll put this one at the end. This is on number 7. Okay? 6, 5. Okay, so 2D bottom up. Yeah, I'm gonna post it, but that's none of the live stream. So I'm gonna end it here and I'll post this there. I'll see you guys tomorrow. Adios.